All right, so this packet, I know we just had a packet, but we have another packet, and we're going to get through it in 4 days. Yeah, because we're pre-calc. It's the beginning's very basic. In fact, this is the same packet you may have even seen in your Algebra 2 class. I give this to my Algebra 2 kids. So a review of basic probability, and then we're going to talk about some conditional probability. That's a little more complicated. And versus or. Eventually we're going to get into counting techniques about permutations and combinations. And that's kind of the main part of today and tomorrow. So, rest of the week we have some more exciting pre-calc stuff, but today should be a nice easy review day, which allows us to go back and revisit some questions off of that yellow SAT packet that we were looking at. Can y'all look at number 1? So, probability is defined as, okay, basic probability is the number of favorable outcomes over the number of possible outcomes. So what a lot of people write down, because that's kind of a mouthful, is they write the number of winners over total. So you've all seen many a probability question before, and usually they're very lame and boring, like you roll a dice and what's the probability that it rolls a 2? You know, things like that. So theoretical versus experimental. Experimental would be based on trials. So we could still do the you roll a die question, but maybe we actually conduct trials and like you roll a die 17 times. How many times did it land on? We do this a lot with the coin toss problem. And then they try to point out to you whether the results match what you thought would happen. Because if you flip a coin, what should be the outcome of landing on heads versus tails? Should be a 50-50 split. But of course, if you only toss the coin like 10 times, you might not get exactly 5 and 5 because that's not large enough of a sample size. But if you flip that coin 10,000 times and you looked at the data, it would be really close to 50% and 50% for both of them. Unless, of course, you have a weird coin that's weighted on one side or something. So the probability of choosing a girl from this class, now I gotta count. 1, 2, 3, 4, 5, 6. Just pretend you're all girls. 7. Did I get 1, 2, 3, 4, 5, 6, 7. So today there are 7 girls. How many total students? Oh, you just came in and ruined my count, yes. There's 8 girls now. All right. So number of students. 1, 2, 3, 4, 5, 6, 7 more. Okay, there's 15 total students. So the probability of me randomly selecting a girl from today's class would be 8 out of our total 15. What's another way to write probability? Decimals, percentages, they all work. So like obviously I'd have to crank that on my calculator, which I don't feel like doing, but fractions work. Oh, a deck of cards. So we found out years ago that kids don't really play cards anymore. So this is a full suit of cards. We don't include jokers. A full deck of cards. How many suits are there? 4. And what are they? So this is the clubs. This is the spades, hearts, and diamonds. What do you notice about hearts and diamonds? They are red, and then clubs and spades are black. And how many are in each suit? 13. And you don't worry about like ranking the cards. Some people argue that ace is high versus low. It depends on the game you're playing, right? So they go from ace all the way up to king, or you can say 2 up to ace, but there's 13 of them. And if I ever say face cards to you, what do I mean by that? Jack, queen, and king, the things with faces. Yes. No jokers when you talk about a suit, a full deck of cards. So the probability that you will randomly pick a red card from a suit, from a deck of cards, we know it's going to be half because we just saw the picture that it's half the deck. But for a lot of kids, they have to start with, oh, well, there's 26 red cards out of the total 52, but of course that's going to reduce to 1/2. How many hearts were in the deck? Yep, a full suit of it would be 13. So that would be 13 out of the 52, but then my logic kicks in and I go, oh, well, that was dumb. Hearts, 1 out of the 4 suits, right? So this is going to reduce to 1/4. A red 7. How many red 7s were in the deck? Yes, there are 2. The 7 of hearts and 7 of diamonds. So that one's a little harder to come up with the reduced one off the top of your head. But 2 out of 52 would reduce to 1/26. And then black heart. There are no such black hearts in a deck. So 0 probability. You will not get that. Wouldn't that be fun? I used to have to put a deck of cards image on the sideboard. Or like tape a deck of cards on the sideboard, yeah. Even after practice problems, they still were like, what? And I felt really bad because I thought, oh, that's really sad. You guys never played with cards. Oh, okay. But you all have seen one of these before, right? We're going to roll a dice, which I always confuse the pluralization. Die, dice. I don't know. I don't like saying die. So if you ever see a problem on a standardized test, like the ACT does these a lot, they don't call them die or dice. They call them a six-sided number cube. Like, beep, beep. I guess, to be fair, there's more than just six-sided number cubes out there. My nerdy husband plays Dungeons & Dragons, and I don't remember how many sides are on that, but it's not a six-sided number cube, so whatever. All right, I digress. Hope he doesn't watch this video. He might. He might. Maybe. Maybe he misses me. Hey, babe. He's not watching it. All right, rolling a 4 on a six-sided number cube. How many 4s are on that dice? 1 out of 6. All right, rolling an even. Well, 2, 4, and 6 would be even, so you could start with 3 out of 6, but that's going to reduce to 1/2. A number greater than 1. So a winner in this case would be a 2, a 3, a 4, a 5, or a 6. So that would be 5 out of 6. And then can you roll a 7? No. Bill, Sue, John, Ann, they're all up for a promotion. The boss is going to select a team of 2 people. We'll talk more about team and whether that's a combination or permutation in the next lesson. But for now, they just want you to show the possible combinations, spoiler alert, of the teams. So I'm not going to write their whole names. I'm just going to say John and Sue, Bill and John. Why did I do that? Stupid. All right, John and Ann, Bill and Sue, Bill and Ann, and Sue and Ann. Did I get them all? Usually I try to do that a little more systematically. I don't know what happened. I didn't. I think I got them all. Now, should I bother like switching the order around? Should I say like Sue and John? No, because that's the same team. It doesn't make a new team. So what's the probability that Bill and Sue will get the promotion? Well, that would be this one team out of the 6, yeah. The team is made up of 2 men. I'm assuming that John and Bill are the only 2 men there. 1 out of 6, yes. Ann is one of the people getting the promotion. So Ann is on the team on how many of these teams? 3 out of the 6, so we'll just write down 1/2. Awesome. So if the sample space is real small like that, there's nothing wrong with writing out the sample space, but sometimes they're not so small. Like this, for instance. A couple's going to have 4 children, and my first question is, why? It's a lot of kids. You need more than a minivan for that. I guess a minivan would work. Write the possible outcomes. Now, birth order would constitute a different outcome. So they're looking at that. Usually we do, in Algebra 2 we did this problem, I don't know if you guys remember, but we had to sit there and list it out, and it was really obnoxious. Because it was like this. These are your outcomes, guys. So instead of making you write them all out, can you figure out how many outcomes we have there? And again, tomorrow we'll learn a better way to figure out how many outcomes. 16, right? Yeah, 16. Cool, cool. So what's the probability that you have girl, 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 girl? 1 out of the 16, yes. Probability that you have boy, 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 which I always thought would be my worst nightmare. But as a parent of 1 boy and 1 girl, I no longer agree with that sentiment. Boys are easier. I know they always tell you that, and I thought they were all lying. They're not lying. Although that's not true. My son does often run into traffic kind of stuff. But my daughter will kill you with psychological warfare. So I don't know what's better. Would you rather just yank your child out of the street every few seconds, or be bludgeoned mentally by a child? Oh, sorry, daughter. She does watch my videos. Okay, all boys. She usually loses interest by now, though. So at least 1 boy. Well, now that's a bit of a problem. I could go through and circle all of the combos here that have at least 1 boy, or can we just say this is the only one that doesn't have a boy, which means all of the other ones do have boys. So That would be 15 out of the 16. That was a little quicker. Okay, fun times. Ah! What is this? Okay, this is a tree diagram. Usually they're the other direction. That's cute. I like that Hofbauer made that. I think she found it on the internet. No offense. No, like, yeah, why would I go make this? Like, look on the internet. That's what it's for. This is what they would have wanted you to do in a tree diagram. You start off with, okay, the first child could either be a girl or a boy. Oops, wrong. Boy or a girl. And then when you have the second child, depending on the outcome, it would keep branching off. So the way a tree diagram works is at the end here, it tells you how many combos you have. So there's 16 little dots at the end there. And you would start at the end or beginning, and you would follow that branch out. So like one possible combination is boy, 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 boy. Or boy, boy, girl, boy, girl. Like as you follow the branch, that's the sequence of the outcome. Tree diagrams are kind of cool, I guess. They're a little easier to look at than the mess of this boy, boy, girl, boy thing. A lot of people like the diagram to look at it a little better. So if you ever see a tree diagram, that's how you read it. All right, guys, probability rules. There's some very general rules that we try to stick to, and then there's some very specific problems in probability that we have to watch out for. There is a little bit of probability on your SAT test. However, what I have found in my experience, the probability from the SAT test is primarily conditional probability. So I'll show you what I mean by that in a second. The probability of an event is denoted by P of A, so the probability of some event occurring. And usually they write it with words, but sometimes they do write it with symbols. But this P parenthesis stuff is indicating probability. The probability of an event has to be between 0 and 1. You can't have a negative probability, and you can't have something over 100%. The closer to 1, the more likely it is. So like a probability of 0.978 means, just like you guys would think, 97.8% probability. The sum of all probabilities of the entire sample space must add up to 1. So like, for instance, if I say things like, oh, for the next question, it talks about the complement. If I say there's a 60% chance of rain today, what else do you know? There's a 40% chance of no rain, right? That's how that would work, because it's either going to rain or not. Although it is Illinois. I don't know. Something in between raining and not. So this is an example that's straight off of an old ACT test. I haven't seen this too much on the SAT test. This is a little basic for the SAT questions. If the probability of an event occurring is 3/5, what's the probability that it will not occur? So you don't really have any context to this probability sample space. So if it happens 3 out of 5 times, how many times does it not happen would be the complement to that. So that would be 2 out of 5 times. That's found mathematically by getting common denominators. So if you don't have a question calculator and you're really worried about fractions, you'd call it 5 out of 5, right? 5 out of 5 minus 3 out of 5. Okay, compound events. So more than one thing is happening. The idea is you multiply them together. Now, we're going to get into trouble when these compound events are not independent from one another. So if they're independent, who cares? Just multiply them together. For instance, if we're rolling a dice and we're flipping a coin, it has no impact on the other event. So what's the probability that you will roll a 5, and then we're going to flip tails on a coin? So let's start with the dice. What's the probability it's going to roll a 5? 1 out of 6, yep. And then flipping a coin, what's the probability it's going to land on tails? 1/2. So the probability that these two events will happen at the same time is you just multiply them together, so that's 1 out of 12. Now here we have a pair of dice, or die, or whatever, but they're still independent from each other, right? So we're still going to multiply them together. And what's the probability that we're going to roll a pair of 3s? So the first time you roll that first die, you have a 1 in 6 chance of rolling a 3, and then same thing for the second dice. And when you multiply them together, you have a 1 in 36 chance of rolling a pair of 3s. This is a question where in probability classes and stats classes, they usually make you draw out the sample space for rolling a pair of dice, and like, it's big because it's got 36 different outcomes, right? So there's this weird chart, and kids always argue with the teacher about rolling a 3 and rolling a 3. Is it different from rolling a 3 and rolling a 3? Yeah, I know, you guys are looking at me like I'm crazy, but this is the question they have for us. So the answer is no. I mean, technically, it's okay. They're like, why does it not show up twice on your chart? Well, because it's the same. I know. people get nervous about probability questions because there's some weird questions out there, right? Oh, this is a very depressing question. Hang with me. The chance of you passing a test for A is 40%. That's not good. The chance of you passing test B is 20%. Huh. Maybe this is one of those tests you don't want to pass. Maybe it's one of those. These are independent from each other. So if you're going to pass, this is so depressing. If you're going to pass A 40% of the time, you're going to fail A 60% of the time. And even worse, you're going to pass B 20% of the time, and you're going to fail B 80% of the time. Yeah. Okay, so they are independent from each other, so we're just going to take the probabilities and multiply them together. Since these are already written as percentages, I'm going to write them as decimals when I go to do my math. So failing A would be 60%, so 0.6. And failing B would be 80%. So you have a 0.48% or a 48% chance of failing both tests. All right, failing A would be 0.6, and passing B would be 0.2. So multiplying those together, you get a 0.12, so a 12% chance of failing A but passing B. And then passing A, let's see, that's 40%, so 0.4. Failing B is 80%. Multiplying those together, you get 32%. And then passing both tests, this is really depressing. 0.4 and 0.2. And when you multiply those together, you have a 0.08, so 8% chance of passing both tests. Huh. Now, can you do me a favor? Can you add these up? Should add up to 1. What we just came up with is called the sample space of the events. So those 4 outcomes are the only possible 4 outcomes here. You're either going to pass, pass, fail, fail, pass, fail, fail, pass, you know. So that's it. So they have to add up to 1 for probability. Which one is most likely? Failing both tests, yes. I think we knew that before we did the calculations. According to our knowledge of failing things. You guys hardly fail anything. You don't even know. All right, dependent events. So what if they are dependent from each other? Well, you can still multiply them together, but you have to remember that the first event occurred and therefore is going to change your probability fraction. So this is the question about like taking something out of a deck of cards or a jar of marbles and you don't put it back. It's called without replacement. So if you have a deck of cards, what's the probability that you will pull 2 aces in a row without replacement? So you still have 2 events, but this time they are dependent from each other. So when I go to reach in the first time and I pull a card, what's the probability that it is an ace? How many aces are in the deck? 4. And let's not bother reducing. Let's just say 4 out of 52. So then I take that ace out of the deck and I go to reach in again. What's the probability the next one is also an ace? Good. 3 out of 51. So there's 1 less ace in the deck and there's also 1 less card in the deck. So now I'm going to multiply those on my calculator. Yeah, I don't know what that is. Don't scoff at me, child. Oh, math enter. Let's do fraction. That sounds like too many things. Oh, that's way easier to look at, right? Totally. So yeah, it's 0.00 something or this. Yes. So unlikely is the answer. And, you know, I'm always amazed by like people who play poker for real because the amount of math that they do, or even if it's informal, they might not like officially calculate everything, but man, it's amazing. Some of them do. Some of them, and they're working with multiple decks of cards. It's not even one. I think that's fabulous. And I don't know how to do it. All right, so if you have 30 students in your class, 17 are boys, 13 are girls, we need to select a president, a vice president. What's the probability of us having a female president and also a female vice president? Well, we have two dependent events. One is going to affect the other because when you are selected as president, you are no longer in the running for vice president. So the first time was the probability that they are going to select a female. 13 out of the 30 kids. So then the next time, 12 out of 29. Good. Let's math enter that one again. 145? Okay. Cool. So that, all right, this one always gets kids. There's two ways to do union probability questions. And the first one is the way that I would like you guys to think about it, simply because these are the types of questions they like to ask in a college level probability course. When they say the probability of A or B, what you're supposed to do is find the probability of A plus the probability of B, but then subtract the probability of A and B happening at the same time. So here's what it means to be a union. Do you guys remember Venn diagrams? Yeah, those are circles. Okay, so this is A, and this is B, and this intersection here would be like the probability of A and B occurring at the same time. So why would we have to subtract it in this formula? Think about what's happening in your Venn diagram. If you were to just add up A, you're adding up this whole circle. So you already counted this little blue piece. So then I go to add up B, and I count that little blue piece again. So because I counted that blue piece twice, you need to subtract it away because you've double counted that overlap. Okay? So it's a little easier to look at when you think of a deck of cards. Kind of. So what's the probability that you're going to pull a red card or a 2? So what you're supposed to think about is the formula. So it would be like the probability of pulling a red card plus the probability of pulling a 2, but then minus the probability of pulling a red 2. That's how you're supposed to use the formula. We'll talk about another way in a moment. But what's the probability, just independent, when I reach in and get a red card? You could say 1/2. I'm just going to say 26 over 52 because of the mental math that I'm going to do. Plus, how many 2s are in the deck? There's 4. But then we're going to have to subtract the red 2s, because didn't we just count them twice? How many red 2s are there? 2 out of 52. So if I didn't have a calculator and I had to calculate this, I would leave them as over 52s for now. 26 plus 4 is 30, minus 2 is 28 over 52, which of course we're going to have to reduce to 7 over 13. Thank you. But a lot of you were looking at that going, why don't you just not count the red 2s twice? That is the other way. So if you go ahead and you handle this subtraction mentally, because you have context to the problem, that's fine. So a lot of kids will look at, I don't want to bring it up again, but the deck of cards, and they'll go, okay, I'm going to count all the red ones, and then I'm going to count the 2 black, the 2 black 2s that I haven't counted yet, and that's a total of, what does it come out to? 28 cards. So potato potato in that example, but I want you guys to know this formula, because oftentimes in your college books, they'll give you things like event A is 0.72, event B is 0.34. So you have to know the formula because there's no context to those questions. All right, rolling a dice. What's the probability that you will roll a 6 or a 3? So you're rolling one time. Now guys, this is kind of a weird question. If you're rolling one dice, can you roll both a 6 and a 3 at the same time? No. So in that case, it's simply the probability of A plus the probability of B, and there's no subtraction because these events are, give yourself a little vocab word here, mutually exclusive. Mutually exclusive. If your two events cannot happen simultaneously, then you don't have to worry about any sort of subtraction. So rolling a 6 or a 3, that could be a 1/6 plus a 1/6. For a lot of kids, they just go, can I just say it's 2 out of 6 because I know how a dice works? And yes, you can. Either way, it ends up being what? A 1 out of 3 chance. There you go. So again, it comes back to when you take a college course, will your professor just be giving you these horrible problems with numbers and no context, or will you get context problems? And the answer is, from my experience, a lot of college professors are still giving the horrible problems with no context. So you have to know the formula. All right, rolling a 6 or an even. So if you use the formula, there is an overlap here, right? Because 6 is also an even number. So rolling a 6 is 1 out of 6. Rolling an even is 3 out of 6. But rolling something that is both 6 and even, that would be 1 out of 6, huh? Because there's a 6 who's also even. So this comes out to 1/2, But a lot of you are looking at that question because of the context going, well, that was stupid. Like, why couldn't I just look at a dice and go, it could be a 2, a 4, or a 6? Yeah, I'm with you. I would have done it that way too. Yes. That was the first page? Should we save the junior-senior problem for tomorrow? Okay. Can you find your yellow packet? That's our next step. Better yet, can I find my yellow packet? Oh yeah, I did that on purpose because I had some kids who didn't have PreCalc, so they... All right, which one? I'm sorry. We did do it? Cool. But we're still on 38? Okay. So 38 is still looking back at that weird chart, that weird table. And it says, no contestant received the same score on 2 different days. Okay. If a contestant is selected at random, what is the probability, good timing, probability that the selected contestant received a 5 on day 2 or a 3? Now, you guys probably, I know you saw it in Algebra 2. We haven't discussed it in our probability packet yet, but when they say the word given, that means something. This is called conditional probability. So it says, given that the contestant received a score of 5 on 1 of the 3 days. So what I used to have my Algebra 2 kids do, and I'm going to have you guys do the same thing, when you have a table of data like this, which is often how they're shown, I do some highlighting, which I know you can't do on your SAT test, so just humor me. But given that the contestant received a score of 5 on 1 of the 3 days. So, right here, right? This is the information about people who scored a 5 somewhere. That's the only place that you're allowed to look on this table for your probability answer. You can only look at these pieces of data. So what should be your denominator? What's the total amount from that data? 7, right? So it's out of 7. Whenever they have this given condition in probability, it changes the way that your data is broken up, I guess. So out of those people that I highlighted, what is the probability that they received a score of 5 on day 2 or on day 3? So add up my 5s from day 2 and day 3. How many are there? 5. The answer is 5 over 7. Now this is also a gridded response question. So a normal human would just bubble in the 5 over 7, but apparently they also would accept the 0.714, which is the decimal. I just feel like that's a bad idea. Like, I would be, as a nervous person in general, I would worry like, oh, what if they don't want me to do a decimal? Like, don't. A fraction's always better. The only reason it wouldn't be better is if, well, make sure it's the right form of the fraction. You can't have a mixed number. And if for some reason the direction said, like, you must express this to a decimal to the nearest tenths place, like, that's different. But if it doesn't, like, probability as a fraction is easier, in my opinion. So leave it as 5 sevens. All right, number 14. So totally different test. And my friends who've been visiting us for SAT prep, this is going to be one that we're going to come up to probably today after school. So we have some more data in a table, and it's about surgeons and their different profession, teaching versus research. And there's 607 surgeons and general and orthopedic surgeons, blah, blah, blah. The results are summarized, blah, blah. If one of the surgeons is selected at random, which of the following is closest to the probability that the selected surgeon is an orthopedic surgeon whose indicated profession is research? So notice the word given did not show up in my problem at all. So that means your denominator is going to be out of the total 607. So you don't restrict your data in any way. So the question is, what's the probability that it's an orthopedic surgeon whose indicated profession is research? So orthopedic research would be these dudes and dudettes, 74 over 607. Apparently they want you to convert that to a decimal. Does that come out to A? Awesome. Very good. So obviously a lot of reading in the probability questions, guys. You can't get around it. It's not as simple as like robot math. You got to really look into it. Oh boy. I don't know about you guys, but I really hate these questions. Like the Roman numeral ones. Is it 1, 1 and 2, 1 and 3, 2 and 3? Like, Now, there are benefits to this question because if you are certain you can eliminate one of the Roman numerals, you can possibly eliminate your way down to the right combination. I just find these to be very tricky. And even more so on the SAT test because literally it's a case of one word. One word they stick in there changes the context of the problem. So we have a polling agency who surveyed 1,000 adults who were selected at random from a large city and asked each adult, are you satisfied with the air in the city? So what do these people all have in common? They live in the city. That's it. Okay, it's not like that book question where like they all love the book and they had to watch the movie. Okay, so they all live in the city. That's all we got. Of those surveyed, 78% responded that they were satisfied with the quality of the air. So which of these is true? Now be careful. There's one coming up on this worksheet, I think, where it says which of the following is false. They just randomly sneak that in there, so be careful. So make sure you're looking for true this time. Of all adults in the city, 78% are satisfied with the quality of air. Do you feel like that is true, false, or you're not sure and can't commit? See a lot of shoulder shrugs, and I see some no's. True, false, or you're not really sure? And like me, I'm very hesitant to cross anything out on a test like this. So I'd probably put a question mark on all of them, and then I'd go back and reread them again. This one's a definite no-no. Do you know what word here makes it a definite no-no? The word all. Anytime they generalize, they overgeneralize with the word all, it's a no-go. You cannot ever say all in probability land. Not a thing. If another 1,000 adults were selected from the city were surveyed, 78% of them would report satisfied with the quality of air. It's an overstep. Yeah, 78% of the ones that they surveyed said yes, but that's a generalization, right? And this is overgeneralizing it, so no. If 1,000 adults were selected at random from a different city, there's your key, different city. Can you take data from this city and say, well, that works for that city too? That's a no. So please tell me none is an option. And it is. Okay, very good. That's very common for your SAT testing. They like to give probability things like this where they give answer choices that are way overgeneralized, because that's a very common mistake for kids. They try to look at probability results and try to apply it like with a gigantic paintbrush to everything, and that's not how it works. So oftentimes none in that case. That would be my suggestion. All right, number 22 from that same test. This question. Okay, so have you noticed there's a lot of words on this packet? Like, that's probably your first thing when you open this packet and flip through it. You're like, holy cats, is this English? What is this? Yeah, probability and stats questions, they don't look like math questions at first. They look like science and Englishy questions, and then you're like, oh, fun. So sometimes when you get overwhelmed with the reading of the math story problems, kind of zone in on what they're actually asking and where do you find those questions in the problems. Generally at the end. So unfortunately this question is like the whole paragraph. It starts here and it ends here. So if students in Mr. Camp's class are representative of students in state's 8th grade classes, and there are 1,800 8th grade classes in the state, that's probably important, which of the following best estimates the number of 8th grader students who have fewer than 2 siblings? Okay, so we're looking for the number of 8th grade students who have fewer than 2 siblings. All right, cool. Let's investigate what's going on here. Mr. Camp, his class has 26 students. Seems important. 34.6%. I hate when they write out the words in a math problem when they could just as easily use the symbol. It drives me crazy. They do it on purpose, by the way. They're trying to see if you can read. I'm not kidding. They are. I know, and that's my argument. They're like, oh, well, they should be able to. Yeah, I know they should, but like they're really adding to the stress here. Okay, so of students reported that they have at least 2 siblings. Cool. The average class size is also 26. Isn't that magical? All right, so we're supposed to figure out how many students in the whole state. Oh, do you see what they did there? Oh, nasty. So when I look at this 34.6%, that's great, but that's talking about kids who have at least 2 siblings. They want to know the complement to that. So what's the other percentage? They don't even want that. 65.4%. So that's how many kids have fewer than 2 siblings in his class. That's what we need to focus on. All right, so with 0.654. I mean, you can multiply it by the 26 kids. That's fine. So you're going to figure out how many kids in each class. But then they want to know all the kids in the whole state. So then you're going to have to multiply it by 1,800 because that's how many classes they have in the state. So multiply all that together for me and tell me one of the answers is close. Please. See? Cool. All right. And it's not going to be exact. They were very careful to not put answer choices that were too close together because of truncation. Like if someone did any rounding earlier on in their problem as they worked through it, they should only have one answer choice that's the closest estimate. Notice they said the best estimate. Okay. So they're not going to put like 30,600 and then like 30,200. That would be really cruel. All right. 27. The mean score. And what does mean mean again? It's the average, which means you guys know how to find averages. You add them all up and divide by how many things you have. So of 8 players in a basketball game was 14.5 points. So you have all these basketball players scoring points. You divided it by 8, and you got an average of 14.5. So that's what I see is happening in that part of the question. Notice they didn't tell me each individual player, and that's okay. So then it says, if you take out the highest score, there's 7 players left over. If you add up all their scores and average it, the average becomes a 12. Well, guys, I think if we do some quick operation work, I think we'll figure out how many total points, and they want to know the highest score. Well, wouldn't that just be the kid that was removed from here to here? So we can just subtract them when we're done. So multiply 14.5 times 8. How many points did they score when they were together as a team? 116. Cool. And then do the same sort of thing here. 12 times 7 is 84. So then the difference would be how much that highest scoring kid made. So 116 minus 84 is 32. The answer is 32. That's a very common question. I've seen something like that show up on almost every single SAT test that I've looked at, where they give you a mean number, but they don't tell you like the individual data from that number. Like they don't tell you add up these 7 things. So you have to know to like kind of set it up with this variable component to it in the numerator. Oh, look, more words. So a researcher conducted a survey to determine whether people in a certain large town prefer watching sports on TV versus attending. The researcher asked 117 people who visited a local restaurant. So, okay. 7 people refused to respond. And which of the following factors makes it least likely that a reliable conclusion can be drawn about the sports watching preferences of all the people in the town? Okay, so basically they're asking you, why was this bad? What did the dude screw up? Okay, so which of the following factors makes it least likely that a reliable conclusion can be drawn about the sports watching preferences? Is it sample size, population size, certain large town, the number of people who refused to respond, or where the survey was given? This is a really hard question. Like I would, if my teacher gave me this question and I got it wrong, quote unquote, according to their key, I'd probably argue it. Yes. Now here's this is why they explain sample size is not the least likely, because you don't know how large the town is. All they did was say it's a large town. Like that could mean something different. Like if I'm from Hicksville, USA, and my town is 14 people, I might think a town of like 112 people or whatever is a lot. And maybe this is like the one restaurant that they have in the town. I don't know. So we don't know enough information to claim that is what SAT was saying. What do you think, Jenna? Okay. Right. Yep. That's exactly their explanation. Well, not verbatim, but you know, I'm with you. That was a lot of like intuitive reading into that, right? I don't know if I would have thought that deeply about that question in the middle of an SAT test. I would have gone with sample size, James. I'm with you. I would have gone with it. I would have got it wrong. The answer is where the survey was given. Where would have been a better place to give the survey? I don't know either. I'm kind of like, can I just claim this is a dumb survey? No, yeah, I'm with you. They're not watching sports. Maybe these people don't care for sports. Or maybe I should sample people who are at a game also and people who are watching it somewhere else. I mean, I don't know. It's just, this is a weird question. I would have argued this one. I'm with you. So they're saying SAT says this is the problem. Hopefully you don't run into that one. Sorry. I don't have a good message for you on that one other than I don't like that question either. Well, oh, you know what? We can get one more done. Why not? Based on the, okay, so we got results of a bar exam for law school graduates. The table summarizes the results of 200 graduates who took the bar exam. If one of the survey graduates who passed the bar exam is chosen at random for an interview. Okay, right there. If one who passed the bar exam is chosen at random. So you're only allowed to look here. Okay? They didn't say the word given or the conditional thing, but that's another way of them saying conditional probability. So you only focus right here, people who passed. What's the probability that they did not, underline, so not take the review course? So how many of those people did not take the review course? 7 out of how many total people in my little subset that I'm allowed to look at? 25. Boom, answer B. Did you notice how 7 over 200 is there? Most common answer for that question because kids don't pick up on the given thing. That was a tricky question. Yeah, but it's going to show up on your test, guys, more than once, so we got to watch out for it. All right.